This lesson is about accuracy and precision. You will find these notes already attached to your notebook. Accuracy and precision can be a little bit confusing. So you need to pay very close attention to what I say and what these words say. If you need to reread them, you reread them. If you have questions, you need to write those down and I'll answer those when I return. The accuracy is the approximation or estimation, is how close it is to the actual answer. So how accurate I am is how close I get to the actual real answer. The precision of a measurement is the level of detail determined by the smallest unit or fraction of a unit that you can reasonably measure. The more decimal places, the more precise the measurement. It's important to note that you cannot be more precise than the smallest measurement that you started the problem with. For example, if your original measurements were to the hundredths place, which is 2 places after the decimal, then all of your calculations must be to the hundredths place. An approximation is a quantity used to represent a true measurement when the exact value cannot be determined or used. When an approximate quantity is used, it is important that we consider its level of accuracy, which is how close it is to the actual answer. When working with measurements, we need to determine the level of accuracy is necessary and practical. For example, a dosage of medicine would need to be very precise. Too much can cause problems, and too little won't address the problem that you're taking the medicine for. An estimation is very different from an approximation because an estimate is made inexact on purpose in order to make your calculations easier or to generalize about a population. An example of a measurement that does not need to be very precise is the distance from your house to the local mall. If you're asked how far you live, if you say about 12 miles, that's close enough. No one needs to know that you live 11.75 miles from the mall. The use of an appropriate unit for measurement is also extremely important. For example, if you want to calculate the diameter of the sun, you would want to choose a very large unit as your measurement of length, such as miles or kilometers. Conversions of units can require approximations as well. Let's move on to some problems that deal with accuracy and precision, or possibly approximation methods. Example 1. For each scenario below, determine if the answer is exact, approximated, or estimated, and explain why. In part A, Cheryl has confirmed 143 guests for her party. She thinks each guest will be able to eat a half a pound of brisket, so she decides to order 0.5 pounds times 150 equals 75 pounds. In this case, Cheryl has estimated because she rounded up from 143 all the way to 150 to make her calculations easy. So you would say this is estimated because she, which is Cheryl, rounded to 150 and, quote, guessed, estimated, they would eat 1/2 pound of meat each. She doesn't know for certain what they will eat. She doesn't know for certain how much she'll need, but she can estimate that she has enough. In part B, John received 4 identical boxes of best-selling books at his bookstore. The first box contained 12 copies of the book, so he figured that the shipment included a total of 48 books. Why is that? This would be considered exact, because if the boxes are identical, he will be able to count that each box has 12 copies, and 12 times 4 is when he got 48. So you need to write, this is exact because boxes are identical. He will be able to count the books when he pulls them out. C. Imani made a flag in the shape of an isosceles right triangle. She wants to put trim along the edges of the flag, so she measures each side with a ruler. She finds that each leg measures 10 inches and the hypotenuse measures 14.1 inches. Now, this is an example of an approximated answer because her ruler is only exact to 1/10 of an inch. If she had a more exact ruler, then her measurement would be more precise. This is approximate because she measured, but is not as precise as she could. So those are some examples about estimated, exact, and approximated situations. Number 2, you are given a diagram of a phone. You are to determine the area of the phone and discuss the accuracy and precision of your answer. Notice, I said to determine the area of the phone, not the screen. So we will focus on the entire phone. This phone is approximately rectangular, even though it does have rounded corners. For that reason, we will use the formula area equals length times width. If I look at the length of the phone, it is approximately 5 inches long. So my width, I will estimate, is 5 inches. My width, I will estimate as 2.5. When I use my calculator to multiply these, I do 5 times 2.5 and I get 12.5 square inches. That is the area of the phone. Now number 3, again, talks about that same phone. It says in example 2, both the length and the width were rounded up to the nearest quarter inch. Try rounding each measurement down to the quarter inch and then calculate the area using those numbers. What's the difference between the calculated areas? So, I'm going to do the area again, and I'm going to measure down to 5 of the length. But this time, instead of going to 2.5, I'm going to go to 2.25. When I multiply those two, I will simply take my calculator, type that into my calculator, 5 times 2.25 to get a measurement of 11.25 inches squared. Now the question is, what's the difference? What's the deal with the difference? Well, the difference is I measured down. Therefore, I've got a smaller area. Because all the way across here, that area now that I've measured smaller is left out. Example 4 tells you that the table below gives the populations from the latest census for 3 nearby counties. Find both the exact answer and the estimation to the total population of the region for all 3 counties and compare the results. If I want to find the exact answer, I'm going to take a calculator and I'm going to add these 3 exact numbers up. If I do that, I get 956,270 people. This is my exact answer because I took those exact numbers and I added them up. Now if I estimate 324,109 people, I say that's about 324,000 people. I would estimate Juniper to be approximately 129,000 people. And for Pinewood, this 8 makes me think I should go ahead and go on up to 530,000. 530,000 for an estimated total of 956,000 people. This is my estimated total. This is exact. This is estimated. When you look at these, estimation was much faster. I could have done that without the use of the calculator just as quick as I use the calculator here. And they are fairly close to the same answer. Number 5 says, in example 4, when would an exact answer be more useful? When would an estimated answer be more useful? So you're talking about, why do you need to know exactly how many people are in your region? Well, you need to know exactly how many people live in a region because of elections. You get representation in Congress based on how many people live in your region. You get emergency funding based on how many people live in your region. That's why when you go to larger cities like Savannah, Savannah has a Savannah Fire Department, whereas we here in Blackshear have mostly volunteer fire departments. Now, an estimate would be useful for a regional population when we're talking about, do we have a major city? So if you just estimated the population around our area, Pierce, Ware, Brantley counties, you would see that we don't have a major city, as if you would have compared some counties up in the metro Atlanta area. They're much larger, okay? So that's a major city versus if you just have small towns. You also need to know an estimate if you want different stores to come to town, because you're not going to get Target in Waycross if you don't have a whole lot of people, especially since we already have Walmart. Now, number 6. Number 6 is talking about scales. Ida works at a deli. She's testing scales at the deli to make sure they are accurate. She uses a weight that is exactly 1 pound and gets the following results. So the weight was 1 pound. Scales 1, 2, and 3 all gave her different measurements. So you need to know which is more precise and why. If I take away the 1 pound weight to each of these, scale 1 is off by 0.019. Scale 2 is off by 0.01, too much. And scale 3 is under by 0.02. The most precise is the one that has the most decimal places. That would be scale 1. Scale 1, because it has the thousandths place. Which scale is more accurate? Which one had the least error? That would be scale 2. Because the weight is closer to the true weight of 1 pound. Now, example 7 is really similar. Sam's a technician in a pharmaceutical lab. Each week, she must test the scales in the lab to make sure they're accurate. She uses the standard mass that is exactly 5 grams and gets the following results. Scale 1, Scale 2, Scale 3. You want to know which is the most precise and why, which is the most accurate. You're looking for which scale for precision has the most decimal places. Scales 1 and 3 only measure to the hundredths place, but scale 2 goes to the thousandths. So which is the most precise? Scale 2, because it measures to the thousandths place. Now, if that standard measurement is 5 grams, we're going to subtract 5 from each of these to find out how much it's off. Scale 1 is off by 0.01. Scale 2 is off by 0.033. Scale 3 is off by 0.02. Which one is off the least? It's the closest to where it's supposed to be. It's the most accurate. That would be scale 1. Scale 1 because it is the closest to 5 grams. So there you have it. You have your accuracy versus your precision. Accuracy is how exact you are. Precision is how many decimal places you are. How much trouble did you go to get the most precise answer that you could?